friends, welcome back to our channel. So in today's session we'll discuss about one more concept in data structures using Python. So that is implementation of stack using linked list. So in our previous session we have discussed about the implementation of stack and queue using a list concept, and now we are going to discuss about the implementation of stack using linked list. Stack using linked list. So we know the concept of linked list, right? So there will be a node, so which consists of two fields. One is a data and another one is the address of the next node. So there will be a link between one node and another node. So here we need to create a one class called a node. Okay, so here we need to initialize the node, so with a constructor. So in Python, so the values for a class will be initialized using the constructor. So def, I go with the init method, okay, and self. So the one parameter will be the self, and obviously the next one is a data, some data. So then it will be self dot data. Two terms will be there: self dot data, which is nothing but x, and self dot next is equal to none. That means, so whenever a node is created, automatically, so two fields will be there. So x will be stored here and none will be stored here, right? So x will be stored here and none will be stored here, right? After that, we need to create a class for stack, right? So class for stack. So here, what are the default values? What are the initialized values? That is nothing but a top, right? So in stack, there will be a top which points towards the first node. That means the first element. So here again, we can go with the constructor self, and here you need not go with any other values. So simply you can write self dot top is equal to none. That means we are creating a top, okay, which is by default it will be none, right? So initially there will be no nodes in our stack, so in that case the self dot top will be none. That means top doesn't point towards any other element. So if one element is being inserted into a stack, immediately we need to change the top. Okay, so this is the basic thing, and we know the operations of a stack. So the operations of a stack are push and pop operations. So push means insertion at end, okay. So being the stack, so always the insertion should be insertion should be at beginning, right? Beginning. Insertion should be always at a beginning, right? And pop means deletion. Deletion, this is also performs from beginning. So the insertion and deletion will be performed from beginning itself. That means the top of the element will be deleted, right? So we need to write these operations inside this class, so that we need to create one object for this class in order to call the operations of a stack. So we'll see majorly three operations. One is a push, pop, and display. So we need to display the elements of a stack, right? So first we will see the push, insertion, right? So I'm writing here the insertion. So before inserting, two cases, okay. So case 1, stack is empty. Stack is empty. So if the stack is empty, that implies top is none. Okay, the top is none. That means some top value is none, right? If the top is none, that implies top is not pointing towards any of the node. That implies the stack is empty. In such a case, what we have to do, we need to insert an element, right? So let it be new is equal to some node of 10, right? So after executing this statement, so one node will be created with a 10 and none, right? 10 and none. That means what happens here? So whenever this executes this one, so now we need to initialize this node because this is only one node. So we have to point the top to this particular node. So that's why we have to go with self.top is equal to new. So automatically the new is pointing the top, right? Top is assigned to new. Top is assigned to new. And by default, the next value is done, or else you can also write it here. So top.next is equal to none. So this is the first case, wherever the stack is empty, right? Now, second case, see, if our stack is having one element, so let it be 10 and this is none, right? So here case 2, so stack is not empty. Stack is not empty now. So stack is having one element. Now in such case we have to add one more element. That means we have to apply the push operation. So here let us take some new is equal to some node of 20, right? Node of 20. So immediately already the stack is having this one, right? Already the stack is having 10 and none. So whenever this statement executes, one more node will be created, right? So this is a 20 and this is none. See, this is a new node. This is a new node and this is a top. Okay, according to the first case, this is a top and this is a new node after executing this one, 20. Now we need to establish a connection between new and top, right? So what happens here? New.next is equal to top. See, new.next means this place is equal to top. So whatever the value at top, that address will be stored here. See, right, 1000. So immediately a link will be established between this node and this node. Okay, link will be established between this node and this node. Now what happens? Top should be assigned to first one. So top is equal to new. So obviously this top will be pointing towards this one. That's it. A simple code. So whenever you insert one more element, new is equal to node of 30. Again, see, one more link will be, one more node is created, 30, and initially it's none. So see, new dot next is equal to top. So this is a new. So new dot next is equal to top. Top means this one. So let it be, the address is 2000. So this will be replaced with 2000. Immediately link will be established and top is equal to new. So now the top will be assigned to here, right? So like this we can add multiple elements one by one, right? So in all these cases the element is being added at the beginning itself because it's a stack. So stack means all the insertions and deletions should be done at the top. Okay, so always the top is nothing but top dot data. This will be top. Now, so I think you understood about this push operation, insertion. Now you go with the pop. That means a deletion operation. See, so very simple. If you draw the diagram, it would be very easy for you to write the code. You need not mug up the code, right? So coming to the deletion. So here case 1. Case 1, stack is empty. So if the stack is empty, what we have to do? Right? If the stack is empty, what we have to do? So simply we have to print it. So what's the case? So if top is none, simply you can print stack is empty. Simple. And case 2, stack is having only single element. Stack with single element. That means only one element. Let it be 10 and none, and this is a top. Okay. Now what we have to do? We need to remove this one. So just you can use, see, top is equal to none. Okay. Then we need to use a top is equal to none only when the stack is having only one element. That means if top dot next is none. So if our stack is having only one element, that implies the top dot next will be none. So if the top dot next is none, that implies top is pointing towards only one node. So in such case, simply we can assign top to none. Okay, sorry, none to top. So obviously it will be removed. So this is the second case. That means a stack with a single element, only the single element, right? So if top dot next is none, simply you can assign none to top. Now case 3. Case 3. Stack with more than one element. One element. Let us take here. So let it be 20 and 1000. So a link will be established here. Let us take one more node, 10 and none, and this is the top. This is the top. Now we need to remove. That means a pop operation. Pop operation means removing the element which is in top. So we need to remove this one, so that we have to change the top to next element. For this, just assign some temporary variable. Okay, assign the top to the temporary variable, and now you can disconnect the connection, right? Disconnect the connection. So after executing this statement, so temp is also pointing towards the first node. So simply you can write temp dot next. See, top is equal to temp dot next. Top is equal to temp dot next. So automatically the temp dot next, what's the temp dot next? Temp dot next is 1000. So which is the address of this one? So immediately the top will be pointing towards here. Top will be pointing towards here. So simply here you can write temp is equal to none. So automatically this node will be deleted and only one element will be there. So this is a simple code for deleting and the deletion of an element where the stack with more than one element. Simple. Temp is equal to top and top is equal to temp dot next and temp is equal to none. So automatically the first node will be removed and the top will be assigned to the second node, because after deleting the first node, then the first node will be second node, right? So the second node becomes the top of the stack. Right? So here in this deletion, 3 cases. One is stack is empty, stack with single element, and stack with more than one element. And the next one, the display operation. So we have successfully done these 2 operations. So push pop, that means insertions and deletions. Now we need to print the elements of a stack. We need to print the elements of a stack, which is nothing but a display function. So here the display function, so case 1, stack is empty. So if the stack is empty, we need to print it. So when we can say if a top dot next is not, sorry, top is none. Okay, top is none. That implies empty stack. Empty stack. So otherwise, what we have to do? Otherwise, case 2, that means the stack is having a more than elements, okay, more number of elements. So simply see here, I'll write the nodes so that it would be easy for us to write the code. Okay, so without drawing the nodes, it would be difficult for me to write the code. 30, 20 and 10, and this is a 2000, so this will be the 2000, and this will be the 3000, and this will be the 1000, and here it is 1000, so link will be established, and this will be none. Okay, and this is a top. What we have to do? So now we are having a more number of elements in the stack, so we need to print each and every element. So for that purpose, we need to print. So we need to traverse this top from first node to the last node. Okay, so we should not move the top, but we have to travel from first node to the last node because we have to display each and every node, right? For that purpose, just assign top to the temporary variable. Now you can move the temp from first node to the last node. The top will be remain same. So here, see what we have to do. So we have to print temp.data. Temp.data. Okay, we need to print temp.data, and immediately after printing temp.data, we have to move this one to the next node. So what is the statement? Temp is equal to temp.next. Now initially the temp is equal to 3000. Immediately temp.data means, see, temp.data means 30 will be printed. Immediately temp is equal to temp.next. So temp is equal to temp.next, temp is 2000. Now temp value is 2000. So immediately 20 is printed. Again temp is equal to temp.data. So temp is equal to temp.data means again 1000, right? 1000. Again data will be printed 10. Next, temp is equal to temp.data. So obviously, sorry, temp is equal to temp.next. Temp.next means none, right? Here temp.next is none. That means we need to repeat this process. So while temp, immediately whenever the temp is equal to none, automatically it will be stopped. Okay, it will be stopped. So we need to write down this code in order to display each and every element of the stack. Here we are checking only two conditions. So one is stack is empty. Another one is just if stack contains more than one element, just we are printing all the elements one by one by using some iterative statements, right? So hope you understood this one, the push operation, pop operation and display operation. So push pop, here the stack means, so both the insertion and deletion will be performed on top of the stack itself, top of the stack, right? So that's why here we call it as a last in first out. The last inserted element will be come out first, right? So hope you understood. So let's stop here. Now we can move on to the computer. I'll show you the implementation of the stack using linked list. So let's move on to the system. Hello friends. So just now we have seen the theoretical part of implementing the stack using linked list. Now we'll write the code. So first let us write down the options for this stack operation. So write down the code. So while one, that means a infinite loop. So write down the options here first. So enter the option from below. I'll maximize this one. Yes, okay, right. Now let us write the options. So print, so one for push operation /n, that means it will display in the second line, so that is a second option. so which is pop operation, and next a new line, go with the third option, which is a display and /n, and the next one fourth exit. Right, now we need to read the option. So option is equal to, so int of input, so it will prompt for the option. Now we need to write down, so if option is equal to 1, simply print what's the option here, push operation. So simply use some dots so that the display will be very clear. So call the function push operation. So we need to write down the class for stack. So all these operations should be called with the help of stack itself. So stack. So S is the object for stack class. So we need to call this push function with s dot push. Similarly, elif option is equal to 2, then it is a pop operation. And here also you just give the lines and call the function pop and elif, and again the third option is equal to 3, which is nothing but a display. So just give the title display and give the lines, call the function s dot display. So we need to write all these functions in the stack class, and else simply you can use a break so that it will exit the program. Now what we have to do, so we need to write all the functions here. So before writing the functions, we need to initialize the node, right, class node, so which will be having a constructor double underscore init double underscore self comma x, which is a node. See self dot x data is equal to x, and self dot next. So every node is having two fields, data and next. So data is x and next is none. Once again, class stack, we need to create a stack class. So there again give the constructor. So with the top, we need to use a top, right? So about this, why we are using self, why we are using init method, everything I have covered in our previous sessions. So that means object oriented concepts in the where what is a constructor and everything I have covered. So I will post the link in the description, so just go through so that you will be understanding everything, right? So self dot top is equal to none. Initially there will be no node, so that's why none. Now we need to write down the functions. First one is a push function. So push, and here we need to read the input. So x is equal to int of input, enter element to be inserted into stack. So now x is a element, just create a node for that one. So node class, pass the parameter x here, so that a node will be created with the data with given x, and next value is none. Now one thing, so where we have to insert, so we have to insert I mean here two cases. One is if the stack is empty, the same node, that means whatever the node we are creating, that will be the top, or else we have to insert the node in the beginning itself, right? Now we have to check whether the stack is empty. So if self dot top is none, that means the top is not assigned to any other element. So then simply you can use, so self dot top is equal to new, and again simply the new dot next, or you can use a self dot top dot next is equal to none, right? Else, that means already if the node is available, then what we have to do, so we need to assign new dot next is equal to, that means we have to insert the element at the beginning itself. So beginning will be the new node and the next node will be the present top. So begin new node dot next should be self dot top, right? Now the self dot top, a link will be established here. Now we need to assign the new node to self dot top. So self dot top is equal to new. That's it. So push operation has been completed. Then pop operation. So that means a deletion. Deletion will also be done from beginning itself. So here also there are three cases. One is the stack is empty. So first let us check self dot top is none. That implies stack is empty. Stack is empty, right? Elif, that means the second case, that means if the stack is having only one element, that means self dot top dot next is none. Self dot top dot text is none. So simply you can use a print popped element is, what's the popped element? Top. So self dot top dot data. Okay, and now so just use line. Now we need to write the code. That means, so now we need to change the top. So self dot top is nothing but self dot next. Self dot next. So the second node will become the top. That's why self dot next. Sorry. We need to use it. Sorry. It is only one node, so automatically we can assign a top to none. Self dot top to none, because this is a case if the stack is having only one node. Okay, then simply self dot top will be none. In the third case, we need to write the code, right? So else, that means the third case. So what we have to do, we need to make the second node as a first node. For that purpose, just go with the temporary variable, assign the top to temporary variable, and now again the same thing. The deletion is top of data. Then we need to assign the next to top. So self dot top is equal to temp dot next, and assign temp is equal to none. That means deleted, right? So simply the second node is becoming the top and the first node becomes none, because temp is nothing but a first node. So very simple code, right? Now the third operation, that is display, def display function. So self, so here you can write the two cases. One is if self dot top is none, that implies print stack is empty. Right? So again here you can use lines. And now second case, if the stack is having a more number of elements, so simply you can print elements of the stack are, so assign the top to the temporary variable. So temp is equal to self dot top, and while temp, so until temp becomes none, that means a false, so simply print temp dot data. Okay, and temp is equal to temp dot next. Temp dot data, temp is equal to temp dot next, and again come out from the loop and print the top of the stack. What is the top of the stack? So top of the stack is, what is the thing? Self dot top dot data, right? So again just give the lines. So the output will be very nice. Right. Now execute. That's all. So push operation, pop operation, and display operation. I think rather than code, the beautification is more number of lines, right? So yeah, execute. Oh, sorry, invalid syntax. It's class node. One second. Just a second. Yes, we have created a stack here, class stack, and class node. I think so. Let us close the. Just, I'm not finding any error. Just I am copying this one. I'll close the Jupyter notebook once and I'll restart the thing. I'll restart this thing. Let us check whether it is still getting the error. Yes. So I'll copy this one. So yes, I've copied this one. Still we are getting the same. Okay, here the class C is a small. Okay, yes, C is a small. Yeah, so it displays the operations. So one push operation, I'll push this 10, and again push operation, enter the element to be inserted into stack 20. Again I'll go with the push operation 30. Again I will go with the push operation 40. Now you can give the display 3. See, display 3 elements of the stack are 40, 30, 20, 10. Top of the stack is 40. Right? Top of the stack is 40. Now go with the pop operation 2. Pop operation, yeah, I think so. Pop takes a 0 positional arguments but was given 1. So let us check here. So here we have not given the self, right? Yeah. Now you can observe here, execute. So I'll go with the 1. So let us insert more number of elements here. So 30 and 40. So display. So top of elements of the stack are 40, 30, 20, 10, and top of the stack is 40. Again, go with the pop operation 2. So pop, again we are getting some sort of error. So typo mistakes. Line 21, it's a typo mistake. It's none. It's none, right? Once again, just go with this one. So 10, 20, 30, 40, 3 display, stack are 40, 30, 21, 2. See, popped element is 40. Popped element is 40 because the deletion operation will be done from the top. So topmost element is 40. So popped element is 40. If you display here, we'll get only 3, 30, 20, 10, and the top of the stack is 30. Still, again, second popped element is 30, and you can observe here. And again, you go with the 3 display. Now 20 and 10 are the elements. Again, second pop element is 20. Again 2. Popped element is 10. Again 2. See, stack is empty. So still, if you try to delete an element which is not available in the stack, so it will print the stack is empty, right? And if you go with a 4, it's an exit. So this is about implementation of stack using linked list. So until you draw the nodes on the paper, So it would be very difficult to imagine and write the code. So if you note down or draw the notes on the paper, simply within a less time you can write the code. You need not by heart, or you need not mug up, right? So hope you understood, and if you are having any doubts regarding this procedure, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.